Okay, here we are going to explore the effects on the area of a shape of carrying out an enlargement. Now, if you look at this diagram, you can see that to go from shape A to shape B, I have enlarged it. I have drawn in already a couple of the ray lines, all right, which show how the corners have moved and where the center of enlargement is. In this case, it's at the point 0, 0. Okay, now I can also see that the shape A has been enlarged by a scale factor 2 to get to the shape B, all right? So I can see that by recognizing that to go from O to here, for example, I've moved 2 places left and 3 places up. So if I go another 2 places left, 2 places right and 3 places up, I'll get to this point here. And another way of looking at it is that this point here is twice as far away from the center of enlargement as this point here. Okay, so the enlargement from A to B, so let me just write that first of all. So A to B, okay, is an enlargement scale factor 2 center 0, 0. Right, okay, so you're familiar with that. Now what I'm going to do now is consider the area and what's happened to it. Well, if I take A, it's got a height of 2 and a length there of 3, all right? And if I look at B, its height's been doubled to 4 and its length has been doubled to 6, all right? You can see that from the squares. Well, the area of shape A is 6, 2 times 3, and the area of shape B is 24, 4 times 6, all right? So the area of A, I'll just write that down. So area or areas, right? A is 6 and B is 24. And hopefully you can see that the area of B is 4 times the area of A. So the area scale factor, okay, the area scale factor of A to B is times 2 times 2, which is times 4. Okay, in other words, if you times the length by 2 and the width by 2, right, you're doubling 2 dimensions, so the resulting effect is the same as timesing by 2 times 2, which is the same as timesing by 4. All right, and if I do a similar thing for A to C, okay, I know that that's an enlargement scale factor 3. Okay, hopefully you can see that by now. Scale factor times 3, and the center is also 0, 0. Okay, so we're familiar enough by now with that, and we can see the dimensions. This has got a height of 6 and a length across here of 9, and 6 times 9 is 54. All right, I'll just write that up here. So 54 is the area of C. Okay, that's the actual area. Okay, now if the area is 54, hopefully you can see that that's 9 times the area of A. Okay, so the area scale factor here, the area scale factor of A to C is times 3, and then times by 3 again, because the length's times 3 and the width's times 3, which is the same as timesing by 9. Okay, and you can see, another way of looking at this is you could see that you could fit 9 of these A's into shape C, couldn't you? If I just divided shape C up into smaller rectangles, look, you can see quite easily that there would be 9 of shape A inside shape C. All right. Oops. Let's put that one in the right place. Okay, so those yellow lines divide this quite convincingly up into 9 of these shape A's. All right, and so when you double the lengths, you times the area by 4. If you triple the lengths, you times the area by 9. If you were to quadruple the lengths, in other words, times them by 4, your area would multiply by 16. Okay, 4 times 4. All right, hopefully that explains area scale factor enlargement. Let me stop that there.